The first part of this question is only worth 1 mark, but we do need to read the question carefully to ensure we answer it correctly. So, my credit card has a 4-digit code called a PIN. You should assume that any 4-digit number from 0000 to 9999 can be a PIN. So, as usual, I'm already picturing the image of going up to a cash machine or buying something with a credit card and having to enter a PIN number. One of the obvious mistakes that people would make here is looking at that number 9999 and thinking that there are 9,999 possible PIN numbers, but then that's missing out the number 0000. So in fact what we should be doing is thinking that there are 10,000 possible PIN numbers. So I'm looking for the probability that I guess it correctly if I cannot remember any of the digits. So this is going to be the probability of guessing correctly will be just made up of the number of ways of guessing correctly, and there is only one correct PIN number that I have, out of the number of guesses possible. So that's 1 out of the 10,000 possible PIN numbers. I may choose to write that as a decimal, though it's absolutely fine to leave it as a fraction. As a decimal, it would be 0.0001. Now, just before moving on, I will just think for a moment, is my answer sensible? There's similar questions that could be asked here, such as how many possible PIN numbers are there, for which the answer would have been 10,000, but this is asking for the probability of guessing correctly. So I am looking for a probability, I'm looking for a number between 0. So the situation has now changed for part 2. In fact, my PIN consists of 4 different digits. I can remember all 4 digits, but cannot remember the correct order. If I now guess my number, find the probability I guess it correctly. So as before, the probability of guessing correctly is the number of correct ways, which is still 1, out of the number of guesses possible. With the extra information, there's no longer 10,000 possible guesses. I know the 4 digits that I'm using. So what I really need to know is how many orders can I arrange those 4 digits in. So one way that people might do is to think about the positions and how many choices of digit you've got in each position. You'd have 4 choices for what goes in the first place, and then 3 choices for the second place, 2 for the third, and 1 for the final place. So that's 4 times 3 times 2 times 1, also known as 4 factorial. Some people just learn that if you have 4 different objects, there are 4 factorial possible arrangements of those objects. So I'm going to be using the formula with 1 over 4 factorial. I can use the calculator. There's a factorial button on the calculator, so 4 shift and then the button that has x factorial written just above it, and that will give me the answer of 1 over 24. Again, I'll just check the question again. It was asking for a probability, so I was expecting a value somewhere between 0 and 1. The mark scheme and some comments from the examiners shown here just confirm everything that's been done previously. Common mistakes were using 9999 rather than 10,000 and not getting the idea of a probability of 1 correct way out of the number of ways possible.